In this one, we're trying to find what's the most axial load we can apply so that we don't violate that anywhere on the plate that the stress is over 21 KSI. Again, for convenience, there's a fillet and there's a hole here that we have to consider. Like we saw in the previous one, we need to make sure that it doesn't fail. We have to see what would it take to fail at the fillet and what would it take to fail at the hole. And then we're going to consider now what would it take overall, what's the most force now that we can apply. Starting at the fillet, we can find that average stress from that calculation on the plot, P over HT, we have P is unknown right now, but H is going to be 2.5 inches. And the thickness is going to be 0.25 inches. So it's P over 2.5 times 0.25. We don't know the load. That's ultimately what we're trying to find. But we know that the stress is going to be 1.6 times that load. Okay, to find the value of K, we need to find R over H and W over H. R, the radius of the fillet, is again 0.25 inches, and the value of H is 2.5 inches. So if I divide those, that means that the first value is 0.1. That's the R over H value. And W over H is going to be 5 inches over 2.5 inches, or 2. The W over H for the fillet tells me which line to use. I'm using W over H equals 2, which, again, it's kind of tough to see from your seat. It's the fourth line from the bottom here is what it's pointing to. So that's the line I want to use. And then I want to see the other value, 0.1. I'm going to see where does this line intersect. R over H is equal to 0.1. So I pass through the first line, the second line, the third, the fourth line. It's tough to see at this size, but it's somewhere around there. So I'm calling that, to the best of my estimation, 2.35 is going to be a close enough estimation. I know my K value. I know the average stress. Now I can find what's the maximum stress. Is going to be 2.35 times 1.6 times P is going to be, I combine this into one. I know that 21 KSI is the most the stress can be at the fillet. And I can set that equal to 1.6 P times the 2.35. So the most force I can apply before it would fail at the fillet is going to be 5.59 kip. Right, so all I'm finding is if the fillet fails, that's the load that it would take to fail the fillet. Separately, I have to consider what is it going to take to fail at the top and bottom of the hole. At the hole, I compute the average stress. I ignore this for the moment, and I'm just concentrating on the hole value. Again, that applied load P over the W of 5 minus the diameter of 1 inch times the thickness of 0.25. The average stress is just equal to P for the hole. For this chart, I need to know where on the x-axis I want to be. So I need to find 2R over W. So the diameter is 1, W is 5, so K of 0.2. So I'd come over to my right-hand plots in this case, see where 0.2 intersects my line. So 0.2 is here. So right there, and that is going to be on 2.45. Same analysis as here. I know that 21 KSI. I can set that equal to sigma max. That's going to be 2.45 times P. So the load that would fail the holes, or fail at the holes at 21 KSI, I would need to apply a load of 8.57 kip. So those are the two places it's likely to fail first, the hole or the fillet. I have to put them together. What is the most load I can apply to the plate before it's going to fail at 21 KSI? So the most I can apply before anything fails is, in this case, the lower of the applied loads. So it is in contrast to the previous example where I needed the higher stress. Here it's the lower load.